What are the types of variables? Two basic types are what? Quantitative and qualitative. And what's an example of a qualitative variable? What's an example of? What? Qualitative. Color. What, like, okay, color. Right. Maybe, what, color of a car. Right. Okay, good. Color is not numerical, right? Does that mean you're not interested in that kind of variable just because it's not a number? Would you ever want to do a study based on car color? Yeah, what, right? You might want to know what's the most popular color or something. So you're interested in that variable. Doesn't just because it's not numeric doesn't mean you're not interested in it, right? So we would like to have ways to work with non-numeric as well as numeric. But as we said before, it's obvious that you can't do the same things to non-numeric that you can do to numeric, right? For example, what can't you do to non-numeric that you can do to numeric? What can you do to numeric that you can't do with non-numeric? Some typical thing you would do with a numeric variable that you couldn't do with a non-numeric variable. I mentioned something last time. What was it? Yeah, you can't calculate the mean, right? You can't take, you have 6 people's favorite color. So 2 people are red, 1 person is blue, and 2 people are white, or something like that. What's the mean of that? It doesn't mean anything, right? So you can't do that. So we need different things. We can do different things with these 2 types of variables. So that's why they bother to distinguish them, right? Because we have, some things we just have to do differently depending on whether it is one or the other type. And then within the quantitative category, there are 2, we distinguish between 2 types. So what are those called? Discrete and continuous, right? So again, there's some things you can do with continuous that you can't do with discrete and vice versa. Well, not vice versa, but so we want to distinguish again with that. Okay, everyone understand that? Okay, good. All right, so that was that one. And then we want to look at cross-section versus time series. Okay, now what's that mean? Anybody know what that means? Okay, what do you think, does anybody know what time series refers to? Time series is, if I have time series data, anybody know what that means? What? Yeah, it means that it's data collected over time. So like, last year, the first day, the second day, the third day, the fourth day, and so on. Every day, or every hour, every minute, or every year, or whatever, we're collecting data. Or in other words, we have data is collected at different times. Okay? So what's, any examples of that are of interest at all? Time series data, any examples of that you can think of? Number of accidents per year. Okay, I mean like car accidents, plane accidents. Yeah. How about Ebola? The number of people who die from Ebola per day, right, in the last year, right? So it's what's happening to that data. It's going up, unfortunately, right? Okay, that's time series because it's over time. But you said number of accidents, right, per day or something like that. How about an example where it would be number of accidents and it's not time series? Yeah, in different locations. Like the number of accidents this year in Oita versus Fukuoka versus Kagoshima versus blah, 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 right? The number of accidents. That's all within this 1 year. We're not measuring different time periods, okay? So, those are interesting for different reasons, right? If you're looking for, some trend over time, then you need time, right? But if you're looking for differences in regions, right, you're not really interested in time there, right? So, sometimes you're asking one kind of question, and sometimes you're asking a different kind of question. So you're going to end up with looking at different kinds of data. Okay? So does everyone understand that? Okay, so time series is data that's collected over time, and cross-section is not. It's not collected over time. Okay? So cross-section data contains information on different elements of a population or sample for the same period of time. Okay, so it's the same period of time, but different locations. Okay, can everybody log into Code School right now, and I'll be right back. So log into Code School. Okay. Let's go back to this for a little while, then we'll go back to Code School. So in cross-section data are collected on different elements at the same point in time. Okay? Same point in time. So you can't distinguish between different times because it's all the same time. Okay, so that's not time series. That's called cross-section. Or the same period of time are called cross-section data. Okay, so here's an example. So what is it? Charitable givings of 6 retailers in 2007. So these retailers, stores, big stores, gave to charity. And this was all in one time frame. And we're not distinguishing, like this one did it on one time and then another time, we're not looking at it like that. We're just looking at it at this time. So we get this data. So this would be called what? What type of data? cross-section, okay. On the other hand, here are total indoor movie screens. And what's going on here? This is not different companies, this is what? Different times. So this is time series, right? 2003, 4, 5, 6, 7, 8. Okay? Everyone get that? Okay, that's that. Now let's go to here. Sources of data, what's that about? Sources of data. Oh, I know. They're just telling you that you can get sources of data. There are a lot of different places where you can get data. But now, there's so many places on the internet. But these are just a few places where you can get economic data and other kinds of data. Okay, how about this? This summation notation, I guess we're going to have to use this at some point. This notation here. So let's just explain that briefly. All right, so suppose I have this okay, so the question is, what does that mean? Okay, so it's not too hard actually. What's that letter?
Sigma.
How do you pronounce that letter?
Sigma.
Right, sigma. And what does it mean to do? It's just sum. And why did they use sigma? Because the word was sum. And that's a Greek S. This is a Greek S. So sometimes they use Greek letters because, if you use like a regular S, for example, it's going to be confusing with other letters and normal writing. So they said, okay, let's use a Greek letter, because then we won't get confused between that and some other just normal writing. Okay, so someone decided that that was a better way to do it. And so we have Greek letters. We use Greek letters. And the reason they use sigma is because it's an S, stands for sum. Okay, so that's what it means sum. So what does this mean? So what it means is, we start with I equals 1, we do something, then we put in I equals 2 and we do something, then we put in I equals 3 and we do it, and then I equals 4 and we do it, and then I equals 5 and then we stop. Okay, so that's what that means. And what do we do each time? This is what we do. So I take I times 2, okay? So first I is equal to 1, what does that give me? 2 times 1. Then I is equal to 2, right? So what does that give me? 2 times 2. Then I is equal to 3, what does that give me? 2 times 3. Then I is equal to 4, what does that give me? 2 times 4. And then 2 times 5, and then we stop. And what do we put in between these? We put plus because it's a sigma. Okay, so we get that plus that. And then, so what is this equal to? Well, we just have to add it up, right? Okay, so what do we get, by the way? What, 30? Okay, I'll take your word for it. 30. Okay? Good. Now how about if I wrote this? Okay, how about if I wrote that? So first we put in I equals 1, we do something. Then we put in I equals 2, we do something. Then we put in I equals 3, and we do something, and we stop. So I put in I equals 1, what do? Multiply that I times 1. Then I put in I equals 2, what do? Multiply that I by 5 again. Sorry, did I say that wrong? And then 5 times 3, right? And what do I put in between these? Plus. Okay, so you get that. How about this? Okay, good. How about this? sometimes you don't have to write the I twice if you don't want to, but it doesn't matter. So now what? First I put in I equals 3, do something, then I equals 4, do something, I equals 5, do something, I equals 6, do something. What do I do each time? I square it, so I get 3 squared, and I do it, I equals 4, so I get 4 squared, 5 squared, and 6 squared, right? And again, what do I put in between? Plus. Okay? And how about this one? So again, what do I do? First I put in I equals 2. What do I get? Then I put in I equals 3. What do I get? And then I put in I equals 4. What do I get? And what do I put in between? Plus. Okay, so this is the sigma notation. Okay, now there is another notation. We don't use it in this class, but you could have this notation. So what letter is that? It's a Greek letter. What's that? Pi. Right, so what do you think this might stand for? If sigma stands for sum, pi might stand for product. Product means multiply. Okay, in this case, what would you do? First you put in I equals 1, you get what? Then you put in I equals 2, what do you get? Then you put in I equals 3, what do you get? Then you put in I equals 4, what do you get? But what do you put in between these? Multiply. Okay? So you would get this. Okay? But we don't use that in this class. But sometimes people will use it somewhere. Okay? So we have this, anyway, but we're focusing on the sigma notation. Okay? And, okay. Any questions about that? Okay, so what do they do here? Okay, so okay, here. So what does it say? Annual salaries for 4 workers are in thousands of dollars, 75, 91, 25, 61. Find sigma x. So what is that? What are you supposed to calculate? This plus this plus this plus this, right? They don't put the I in here, right? Because they assume you can guess what they mean. Okay? How about this one? What would you do? You do the same thing that you just did here, and then at the end, you would square the result. Okay? Whereas, how about this one? This is not that. This is different, right? What's the difference between this one and this one? Here you do this first, and then square. Here what they mean is, you square each one, and then add them up. Okay? So they're just pointing out that these mean different things. Okay? And here's another example. And here, we have some M values and some F values. F usually stands for frequency, but right now it doesn't stand for that, but that's... Anyway, so if you wanted to do sigma M, what would you do? These, you'd add those up, right? And if you did sigma F squared, what would that be? Square this, square this, square this, square this, and add them, right? Okay, now how about this one now? What does this mean? Not exactly clear, but I think because they didn't write all of what they should have written. But anyway, can you guess what this is? You take this times this, and then this times this, then this times this, then this times this, and what do you do with those 4 products? you add them up. Is that clear? If I skip too fast, you have to let me know. How about here? Or you can go back and look at the video and stop it. How about this one? So what do? You square it as 12. So you get 12 squared times what? 5. That's your first term. Okay, then what do? You square the 15 and multiply by 9. That's your second term. You do it here and here, and then what do finally with all 4 terms? You add them up. Okay, so they do it here for us, right? Okay, so you can see that. Anybody have any questions? So what is all this? This is another way to just show how they did it. It's just a table of the different ones. Okay? Any questions about this? How about this one? Let's try this one. The following table contains information on the NCAA Men's Basketball Championship Tournament Final 4 teams for the 31-year period between here and here. The table shows how many teams with each seeding qualified for the Final 4 during these 3 years. So what does that mean, seeding? I don't know what that means. Anybody know what that means? Seed 1, 2. I don't know what that means. So I'm going to skip that. Okay, how about this one? No. Okay, these are all kind of simple. Okay, let's go on. Okay, so we did that. Any questions about chapter 1? Okay. Let's go to chapter 2. Does everybody have such slow internet? Where is chapter? How do I get out of here? Hold on here. Okay. Chapter 1. Okay. Chapter 2, organizing and graphing data. So when they say organizing data, the idea is, if I give you, let's see, one of my favorite websites for what I do is this website called KD Nuggets for data mining. Now here they have data sets. So this has lots of stuff here. They have data mining courses and jobs and so on. So let's look at the data sets though. So government, federal, city, state, Amazon Web Services, Canada Open Data. Anything interesting here? Public data put to good use. Let's see what that's about. And how about hit companies, investor data, financial data. We have lots of data here. Cancer data, million song data set. What's that? Okay, let's see, what was that million song data set? Abraham songs. Well, that's the FM data set. Okay, let's see what that is. Last FM. Getting the data set. Subset, let's try that. Why is APU's website, web data, internet so slow? Is it slow for everybody? What is that? Used to be good last year. To complain. This one didn't work. Anybody see anything good here? How about sports? Sports, women in baseball, cycling, football, basketball, hockey. Okay, let's see this. Okay, let's look at basketball. Women's basketball. Download. Okay, there. That one's coming in. Okay, so we look, oh, we have all that data in our website, right? Forgot about that. We have, in our, at Wiley, they give us a lot of data. Forgot about that. Okay, here it is. Okay, let's see, which one is big? This one's really big. Players. Okay, so here we have all this data. How many rows of data are there? Starts at 2, and it goes down to 3,000 and something, right? Okay, so the point is that without summarizing this, it's really, almost useless, right? It's just a million numbers, right? Our brains don't work well just looking at millions of numbers, right? We can't really do anything with it, right? Just mess. So we want to summarize it, right? So how can we summarize it? What do we mean by summarize it? How can we make it somehow interesting or useful or something, just more than just a bunch of numbers? Anybody? Make it into a graph. Yeah. Okay, that's one thing. So let's do that. And what else can we do? Excel does a lot of stuff pretty well. It can make nice graphs. What else can it do? How about this function up here? You know that one? Auto sum? You don't know that? Okay, let's look at it. What's an interesting column here? You know what rebounds means? Like, I think that's when someone tries to make the basket doesn't go in and somebody else sort of hits it and makes it go in afterwards. I think that's called a rebound. No? Isn't that called a rebound?
The ball doesn't go in and you get the ball for the second chance.
Yeah. Isn't that it?
That is called a rebound.
Okay, all right, so it's something like what I said. So that's kind of interesting. So one thing you could do is find the average rebounds. And that's easy to do in Excel. This is the column. Let me just mark it so that I can see it. Okay, so that's the column. You just go down to the bottom, just click in the bottom cell, and you just click here, and you get the average. Okay? Just click average, and then hit enter. And it's kind of slow. Didn't work. There. So the average rebound is whatever that 25, I don't know even what that means. 25 what? Points per game? No, 25 points per person. Maybe that's 25 or 25 rebounds per person per year or something like that. Okay? 'Cause I'm not really sure what these numbers refer to, but I think that's what it is. Okay? So you can get the average, right? Or, and so on. So average is one thing that takes a huge set of data and summarizes it somehow, right? And then, like he said, you can also do graphs, right? So you could do a graph of this data as well. I don't know, a graph is going to be pretty messy because we have 3,000 rows, so it's going to look kind of messy. So I'm not going to do that. But what you could do is you could summarize, well, let's not get into that now. Okay, so anyway, that's the idea here. So this section is called what? This chapter is called what? Organizing and graphing data. That's what when you have a huge set of data, you want to do something with it. Otherwise, it's not comprehensible. Okay, so we can start out with, what's this thing? Raw data. What would that mean? We haven't done anything to it yet. We haven't summarized it or transformed it or done anything to it. It's just raw. Okay, and then what will we do in section 2.2? Organize and graph it. And we'll focus on which kind of data first? Qualitative, not quantitative. Remember that we said you can do certain things for one and other things for others, so you can't do the same things. So they're going to talk about one type and then the other type. And we're going to talk about what's called a histogram, which is just like a graph, and these are other ways to graph it. This is called a stem and leaf display and a dot plot. Let's just look at that. What's a stem and leaf display? This is called a stem and leaf display. Okay, so does anybody know how to read this? What this is, ready? How many pieces of data do you think are represented here? Well, here's the way it looks. There's a 52 in this data set. There's a 50 in this data set. There's a 57 in this data set. Do you see what I'm doing? Everyone understand? There's a what in this data set? A 65 in this data set. There's a what else? 69 in this data set. There's what else? That's kind of weird. Usually they order them. But anyway, there's a 61 in this data set. What else is there? There's a 68. And there's a what else in 60s? 64. Does everyone get this? Okay, how about here? There's a 90 what? 6, right? There's a 93. How many 92s are there? There's 2 92s, right? Understand how it works? Okay? So this is called a stem and leaf plot. A stem and leaf plot. Okay? Usually they do it in order like this. So here they reordered it. Okay? But that's, anyway, okay? Everyone understand that? So this is a way to this is kind of a clever way to kind of graph the data. Because which set of numbers occurred most frequently? What I mean is, which unit of 10 occurred most frequently? 50s, 60s, 70s, 80s, or 90s? Which ones? 70s, right? And you can see that right away, right? Now think about if this was just randomly displayed data. In other words, if it looked just like this, you don't know that 70 occurred more than any other, right? Right? But if you look at it this way, you immediately know that 70 occurred more than the others, right? So that's an advantage of doing this, right? It shows you information very quickly. Okay, everyone understand? So they call this a ranked stem and leaf because they put it in order. Whereas this is just called a stem and leaf. Okay? And you can even give me a quick estimate of the average. By the way, what is this data? Here, what does this say? Scores for what? Statistics tests, right? So you can, now if you just look at this, you can't really give me an estimate of the average score, right? I mean, maybe you can, but I don't think so. Okay? Whereas, if you look at this, you can give me an estimate. It's not going to be perfect, but you can get a very quickly, you can get an estimate. Right? What is the estimate, approximately? Somewhere in the 70s, right? Maybe 75 or something like that, right? So, now, you don't do that if you have this data. You have it displayed like this, right? It's not easy to do that. Okay? So that's the point of graphing data, is that you can see things that you can't see otherwise. Right? Which is true, right? You can see things that you can't see otherwise. And that's why you do it. Okay? So, so this is useful. Right? It shows you, how about this one? This is what? Monthly rents paid, right? Now if you just look at this, it's pretty hard to give an estimate of the average. But if you organize it like this, now you can get an estimate of the approximate typical monthly rent, right? Everyone agree? What is it approximately? I don't know, maybe 10 something, right? Something like that. Low tens. Right? Okay? So that's that. What's this one? Number of hours that 25 students spent working on their computers. Okay? So, when we look at it this way, we get a feeling for the data. Okay? That's the point of doing it. Okay? It's so that you can understand what is just a bunch of messy numbers. Okay? So that's called section 2.6. Now dot plots are almost the same, I think. Yeah, it's basically the same thing, but it looks like this. Okay? So here, what does this dot mean? Oh, sorry, you don't know. Let me explain this. What does this dot mean? It means there was one, what is this? The longest completed field goal. Now, do you know what a field goal is? No. That's in American football. It's like the guy kicks it and he tries to get it through the goal. And he could be anywhere on the field, and he has to try and do it. So obviously if you're further away, it's harder, right? So there were two cases where somebody completed the field goal at 57 yards or 57 meters from the goal post. Okay? So the fact that there are two dots, one on top of each other, means there were two cases of 57. Okay? And this must be 56. There were also two cases of 56. And there was only one case where somebody was 55, say, meters from there, and they completed a goal. And so on. How about how many cases where there were 53? 4. Okay, so this is called a dot plot. It's a little different than what I said for the stem and leaf, right? But still, it's a way of organizing and visualizing or graphing the data. Okay, everyone get that? Okay, so that's called, what's this called again? A dot plot, right? Okay, so we have dot plots. And here they talk about uses and misuses of data. That's always, I mean, of statistics, that's always important. So you can fool people by showing them certain kinds of pictures. Even though the pictures are accurate, the way that you choose to sort of present it can fool people. So they give some different ways. For example, truncating the axes. So what do they mean here? This is about identity theft. You know what that is? Somebody gets your identity and uses it. So they present it this way. What's the axis? The y-axis goes from what to what here? From 0 to 160, right? But notice that none of these actually drop below about 80, right? So they could also present it like this, 80, right? But that makes the differences look a lot more, right? Like this looks like it's what? Like 5, 6 times, Arizona has 6 times as much as New York, right? Or something like that, right? You see that? But if you look at it like this, you wouldn't say that, right? So you can confuse people by doing that. So if you want to cheat, that's how you can do it. Okay? Or that's not the point of the exercise. The point is to say, no, you should be aware that somebody might try to cheat you, right? So you should know that this could happen. Okay, so you have to be careful, for example, looking at the axes. Okay? And maybe here's another. How do they do that? I don't know. There are many possible misinterpretations as a result of using the pie chart. For example, a person might look at the graph and believe that 17.4% of all identity theft cases occur in Arizona. Yeah, I would think that. Isn't that what it means? Right. 17 of all identity cases, but that's not true. It's 17.4% of this group, right? So that's one thing. First, only 8 states are represented in this chart, so all of the percentages are overstated with respect to the entire United States, right? Second, and more important, the percentages are based on the sums of the state rates per 1,000 people. This cannot be done unless all the states have the same population. So that's another issue. Anyway, so the point is, there's lots of ways to misread charts. Okay? Okay. Let's go back to the beginning of this. So raw data. So what is raw data? Data recorded in the sequence in which they are collected. So it's just, it's not ordered. You don't order it at all. You just take, I got this piece, and I got this piece, and I got this piece. And before they are processed or ranked, right? So it's not graphed, it's not averaged, it's not anything. It's not even ranked. It's not even ordered. Okay, that's called raw data, just as it was collected. So here's some raw data, right? The ages of 50 students. Okay, that's raw data. Suppose we ask the same 50 students about their student status. The responses of the students are recorded here. Now we're talking about freshman, sophomore, junior, and senior. Okay, so now we get this data. Okay, now, which of these, which one is clearly numeric data? The age is clearly numeric. Now you might argue that this is also kind of numeric, right? Because there's kind of order there, right? Freshman is before sophomore, sophomore is before, right? So that's a little bit, right? You can't really say whether this is numeric or not. Exactly. Because so that brings up the point that we can distinguish between like strictly numerical and ordered data. Okay, ordered is still a kind of number, right? Okay, so sometimes that's important to distinguish. So data presented in tables 2.1 and 2.2 are called ungrouped data. And an ungrouped data set contains information on each member of a sample or population individually. Okay, so this hasn't been grouped at all. Later we could say, how many juniors are there, right? We could count that up. That would be like grouping it into juniors, sophomores, seniors, and freshmen, right? But right now it's not grouped at all. Okay, all right, let's go on to the next one. This one. So now which kind of data are we going to deal with first? Quantitative or qualitative? This section is on qualitative data. The question is we might call that last one, I said, we could call it ordered or we could maybe call it qualitative. Okay? It would be a little bit of a mistake to call it strictly qualitative. Because if you call it strictly qualitative, you're losing some information. What information? What do I mean you're losing some information? Because if you just call it qualitative, you're forgetting that freshman comes before sophomore, sophomore comes before junior, junior comes before. So you kind of lose that if you just call it qualitative. So that's kind of throwing away information. So you don't exactly want to do that, but still might be useful. Okay, let's see. So let's take this data. So what was in those last two that we just looked at, what were the two variables? Age and what do we call that? Grade or something, year, right? Whatever. What did they call it? What did they? This one. Status. They called it status. Okay. So what were the two variables? Age and status, right? Okay, now, what are we doing? A sample of 100 students enrolled at the university were asked what they intended to do after graduation. Okay? So we're collecting data here. We're not collecting their age, we're not collecting their status, we're collecting this. Okay? We're collecting what? What they intend to do after graduation. I could ask you right now, what do you intend to do after you graduate, right? And we have 20 students or 25 students here. Go ahead, get some answers, right? Okay, so that I can call, so age is a variable, status is a variable. Status, I'm not sure whether it's numeric or not, but age I'm sure is numeric. But this is also a variable, but it's definitely not numeric, right? It's not numeric, okay? So what they intended to do after graduation, it's still a variable though, right? So we've got some answers. Private companies and businesses, federal government, state and local government, and their own business. Okay? So how many were going to go to private companies and businesses? 44. How many were going to go to federal government? 16. How many were going to go to this? 23. This? 17. Okay, when you sum up these numbers, you get what? 100, because you asked 100 people. Okay? So this is a variable. What should we call the name of this variable? We may as well call it type of employment. Right? Or if you want to just make it short, you can call it type or something, or employment. Right? But it's a variable, right? But it's not numeric. The fact that there are numbers here doesn't mean it's numeric. Right? Because you ask, what are the values that the variable can take? So if you think about age, what are the values that age can take? Whatever, 0, 1, 2, 3, 4, up to 100 or something, right? Okay? Now, if I ask you, what are the values that this variable can take? Employment, it looks like it can take on how many different ones? 4, and what are they? Business, federal, right? So that is definitely not numbers. That variable does not take on numeric values. So it's not numeric. Okay? So what determines whether it's numeric or not are the values that it can take. Okay? So this is not numeric data. Okay, so therefore it's qualitative data. Okay, the fact that there are numbers here doesn't mean anything about that question. Okay? This is just how many people, vote for this, or want to do this, and how many people want to do this, right? Okay? All right, so any questions about that? So they say the variable is type of employment, which is a qualitative variable. Okay? Now, you guys learned some R, right? A little bit of R. And in R, the language they use for the values that the variable can take, they call them the different levels that the variable can take. So the different levels that employment can take are private company, federal government, state and local, owned business. Those are called they call them levels in R. So when you read a book about R, they refer to the levels. Okay? And the levels means the values that the variable, I think it's, specifically use the word levels when you're talking about qualitative data. Okay? And one more thing about R is they don't use the word qualitative. They use a different word. Okay? They don't call it qualitative, they call it factors. That's a kind of, I think, well, I don't know, maybe that's from psychology or something. Anyway, they don't call it qualitative, they call it factors, usually. Okay? So factors have levels. Right? Everyone understand? So remember that, try to remember that when we study some more R. Okay, does anybody have any questions so far? Okay. Let's go and study some R now. So let's go to where we were supposed to log into here. Now I asked you to go to section 2, right? Chapter 2, right? In Tri-R. Let's also, at the same time, open up R in our computer. Did anybody have any trouble downloading R onto your home computer? So remember, all you have to do is go to type in R programming. Sometimes just R itself will work. And here it is, the R project. You don't have to do this because we already have it here, but if you want to do it at home, then you go download R, and you choose somewhere to download it from. And you download Windows if you have a Windows computer. And install it for the first time. and download. And it's 54 megabytes. Okay, and as we saw here at APU, it's not going very quickly. So I'm not getting anywhere with that. But you can do it quickly at home. And just go click, 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 and it's in. And then once you have it in, then you can go and find it in your here, and go here, and here I want to use the later version here, which is this one. You open it up, you get that. Okay, and I'll make this bigger. Go to GUI, preferences, and here. Okay, like that. Okay, now let's go to here and here. Okay, now let's go to vectors, chapter 2. Now, if you didn't even complete chapter 1, you can't access chapter 2 yet. So that's your fault, because you're supposed to complete chapter 2 as well. Now, if you already did these, you can click here, see where it says that when you put the pointer over that, you get that, so you can redo this if you want to. Okay, so I'm expecting that you at least completed chapter 1, so I'm going to start here. So vectors. What is a vector in R? Well, this is a vector. Well, first of all, you should have done things like this. What is this going to give me? What's that going to give me? A sequence of numbers between 8 and 14, like that, right? But that's called in R, that's called a vector of numbers between 8 and 14 instead of a sequence of numbers. Okay? But this is not very flexible because this forces me to have just, 8, then 9. It has to be the number, just can't have different order or anything like that, right? So trying to make vectors, like this wouldn't be very good. So that's not this is good for generating a sequence, but that's not how you generate a vector in general. So this is how you generate a vector in general. So you use this C function, and C stands for combine. So you want to combine 4, 7, and 9, so you just do that, and hit enter, and you get a vector like that, 4, 7, and 9. Okay, which is obviously more flexible than just doing it the other way, which we couldn't get this. It's called combine, or it's also called concatenate. Okay, so either way, it's this function, C. And you can also do this, and this is a vector of numbers, but this is a vector not of numbers, these are strings. So you do that, and you get a vector of strings. Okay? Any question about that? And if you want to do, okay, let's say that. And then they say an important thing about vectors is that they can hold different types. And by types they mean like numbers versus strings versus other things. You can't have one vector holding different types. So they all have to be numbers, or they all have to be strings, or whatever else there can be, but they all have to be the same. And then they give you an example of that by doing this. Look at this one. What are we putting together? Now, this one is not actually a string. It's called a logical value. It can only be true or false. Okay? And the way that you type it is you type either capitals true or capitals false, and you don't put quotes around it. If you put quotes around it, it just becomes a string. That's different than this. This is different. This has a special power that strings don't have. Okay? So to type it, though, you don't put quotes around it, otherwise it would be just a string. Okay, now the question is, what's going to happen when we do this? Because we just said that you can't have different types in a vector. But we're trying to put different types in a vector right now. So it's going to do one of two things. Either it's going to give us an error, which it doesn't do, or it's going to somehow convert everything to one type. Now, it's going to be a little bit hard to convert true to a number, right? And even, suppose it said dog, right? It's going to be a little bit hard to convert dog to a number, right? There's no sensible way to do that, right? So what it does instead is it converts everything to strings. Okay? So if you run this, it converts everything to a string. So this is not a number anymore. This is a string. And this is not a logical value anymore, it's just a string. Okay? Everyone understand? Okay, now, we already saw that you can make a sequence, a vector of a sequence like this, right? Right? Now, this is another way to do that. So if you run this one, so this is sequence from 5 to 9, same thing as this one was. Okay? So if you do it, what do you get? That. Okay, the same thing as what you did before. However, this is more flexible because you can run this. Now, what does this mean? It means that. Okay, so what does it mean? It means you go from 5 to 9, but you go in half units, increments, right? Okay? And we know what this does already, right? Does that, right? Any questions about that? So it just goes down. Okay, any question? Okay, now, here they say, we're going to create a vector with some strings in it for you and store it in the sentence variable. So we're going to remember this here. What does this mean? Sorry, can't do that. What does that mean here? That's the assignment operator, it's called. It means we're assigning something to a variable called what? Sentence, right? We're assigning something to a variable called sentence. What are we assigning to the variable called sentence? A vector of numbers? No, a vector of strings, right? Okay, so we do it. And finally, it's starting to download. Finally, R is starting to download. Okay, anyway, so here I run that, and nothing, I don't see anything here. Okay, after you run it. Because it just stored it in sentence. If you want to print it, you can type, I don't know if this works on this web page, but it would work in R. Just do that, yeah. What? Oh, sorry, they're asking us for a different thing. Okay, but if you type sentence, you can see what it is. By the way, I think the way this web page works is it accepts this black box here is like a text box in a web page. So we type something into the text box, it sends it back to the server, wherever the server is, where they have R running. It runs it in R and then sends us back the result. So I think that's the way this works. But anyway, so, okay, so what do they say? You can retrieve, okay, so what does sentence have in it? Walk the plank, 3 elements, each of which is a string. Sentence is a vector, right? Okay, now you can access individual elements of a vector. Okay? So if I want to access the third element in the vector sentence, what is the third element in the vector sentence? Plank. So hopefully this will generate what? Plank, which is the third element in the sentence vector. Okay? So you can run the same code in your R. By the way, if I wanted to install R, finally it downloaded. Here it is. Right? Of course, you just click it, go here, and just keep going, right? And you can install it. Okay, many languages start array indices at 0, but R vector indices start at 1. What do they mean by that? What do you think is the index for this one is 3, okay? And the index for this one is what? 1. But actually, believe it or not, most programming languages wouldn't call this the first element, they'd call it the 0th element. But R doesn't do that. But almost every other programming language does. Okay, so that's a little bit unusual, but on the other hand, it's quite natural. Okay? So anyway, that's the way it works in R. So sentence 1 is going to give us what? Sentence index 1 is going to give us what? Walk. Okay? Now they say you can reassign the element in the third place by referring to the third place of sentence and reassigning it. Okay? So you can run this, and what's sentence going to be? If I type, so what will sentence now be? Walk the dog, right? And I can, now, what does this mean here? There is no fourth element, right? But I can add one in, okay? And what is it going to be? 2, a string. Okay? So I don't know if I can type here, but yeah. Okay? And then you can use, okay, any questions so far? Now suppose you want to access just, what was the first and the third? Walk and dog. You just want to access 2 elements. How can you do that? We know how you can access a single element, like this, right, or here, but how can you access 2 elements? Okay? So you might think, oh, I could just put in, without the C here, you might just think I could just put in what? Sentence 1, comma 3 or something like that, but that won't work. Okay, let's try it. Okay, you think that will work? Let's see. No. Okay, that doesn't work, that's not the syntax. Okay, any question? Now, what kind of brackets are those? Are those round brackets or square brackets? They're what? They're square brackets, right? So note that, right? You have to be using square brackets. What are round brackets used for, by the way? Where have we seen round brackets? For functions. Okay, round brackets are for functions, square brackets are for this. Okay? This is called indexing or extracting. Okay? So do you see any round brackets here? Yes or no? Yeah, why? Because we're using what function? The combined function, right? So that means round brackets. Okay, what does this give me, just the inside part? Just the C. What does it give me? It gives me a vector, right? Okay? Now you might think that I just wrote the same vector right here, so why can't I do it? Right? Don't you think that? Because this is just giving me what? If I just typed in, I don't know if this works in this interface, but let's see. Yeah, that just gives me 1, 3, right? So why can't I just type in 1, 3? First of all, I have a comma here. Let's see, I forget if this works. Does this work? No. Even that doesn't work, right? So it's a little bit troublesome, right? It doesn't work exactly the way we want it to work. How do we have to do it if we want to get those 2 elements, the first and the third element, out of sentence? We have to use the combine function inside to create a vector. Okay? In other words, it has to have a vector in order to extract those elements. Okay, so if we finally do it the way they told us to do it, like that, then we will get what? Walk and dog. Okay, does everyone get it? Any questions? Now this one, how about this? Do you think this might work? Well, let me put it this way. Square brackets inside, you sort of have to have a vector. So do you think this will work? Yeah, because 2, I call it 4, will produce a vector, right? So what elements are we going to get this time? What are we getting? Where is it? I don't know. All right, let's see. I forget what it is. The dog 2. Okay? We get the second, third, and fourth elements. Right? Okay, how about now? What's this doing? What's that doing? Well, there are no 5, 6, or 7 elements, right? So what are we doing? We're creating those elements, and we're filling them with 3 strings, right? So we can do this. And now there are all of it. So how do we get the 6th element of sentence? What do you type? Sentence, open square bracket, 6, close square bracket, right? How about if I wanted the 6th and the 7th, though? So I need the combine function, or I could use the sequence function. What was, oh, I hit the wrong key there. Okay? Anyway. Okay, any questions about that? Okay, vector names. See, oh, okay, so you, for homework, you should do 2 and 3. Okay, and we'll have a quiz on that, as well as possibly a quiz on chapter 2 of Wiley. Let's just continue a little bit more with Wiley. So, because we didn't do this. Okay, so a frequency distribution for qualitative data. So what kind of data is this? It looks like qualitative data. Right? Again, it has some kind of order in it, but we're going to treat it as qualitative. Okay, understand? This is how stressful their jobs are. Okay? So the answers are somewhat, none, somewhat, very, and so on. Okay? So what could we call this variable? Anybody want to give it a name? What? Stress? Okay, good. Stress or stress level? Okay, good. And is it quantitative or qualitative? Qualitative. In R, what do they call qualitative data? What is it called? Factors. And what are the values that this data can take? Sorry, what are the values that this data can take? Somewhat, none, very, anything else? No, just somewhat, none, very, right? And in R, what do they call the values? Levels, right? So there are 3 levels for this factor. Okay, understand that for R? Okay, anyway, they're not doing R in this book. So they say though, how can we make some kind of sense out of this data? What would you do with this data? We saw that we could, when we did the dot plot and the stem and leaf, that was for numeric data. and we could make some sense out of it, instead of just having to look at a big set of data. So how could you organize this data? What would you do? If you were trying to analyze, oh, let's see, I got all these people, and what's going on with them, what would you do? I mean, you'd say, okay, well, somebody said somewhat, somebody said none, but you might try to do a little bit more than that. What might you do? Count them, right? You might try and count how many what? How many somewhats, how many nones, and how many varies, right? And that's called a frequency distribution. Okay? So how many varies, how many somewhats, and how many nones? So there were how many varies? 10, how many somewhats? 14, how many nones? Okay? And this is just a tally, right? You count them, 1, 2, 3, 4, 5, 6, 7, 8. It's just called a tally. Okay? So that's a natural thing that most people would, everybody would do eventually with that kind of data, right? Is make a frequency. And then once you have this, you can actually graph it. Okay? How would you graph it? You could do this. Vary, somewhat, none. Right? So you could make a graph, even though it's not numeric data, because you counted. Okay? Which is not very startling, right? It's something that everybody would do. And they also define the relative frequency of a category. So that's here. How many varies were there? 10. How many somewhats were there? 14. How many nones were there? 6. So what are they doing here? The total number of people was how many that they asked? 30. So what are they doing there? They're saying 10 out of 30, right? So that's just the relative, it's called the relative frequency, right? Which is another thing that would naturally, you would do, right? You'd say what? 33% said vary, right? And then what would you do here? 14 out of 30, or what? About 46 or 47% said somewhat. And what would you do here? You'd say 20% said none, right? So this column is called what? Relative frequency. So this column, sorry, without the dividing by 30, we called that what? The frequency, right? When we divide by 30, we call it the what? The relative frequency, right? Why? Because relative to the total number, right? Okay, that's all for today. I'll assign you more homework, and you should, let's see. I might, anyway, for the, if you have a test on this, I won't ask you about 2.3, 2.4, okay? But I might ask you up to 2.2 on the quiz. Okay, but I might ask you to do homework on more than that, but I won't ask you on a quiz about that. Okay? So that we can go over it. Okay, and also you have to do up to chapter 3, through chapter 3, including chapter 3 for the R homework. Okay? Okay, that's all. And I'll try to post this video. I didn't make a video. Well, I made some, but I didn't finish. I did an hour and 20 minutes.